بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Stat 101 Major 2 Term 221. The first question is about says a company is studying the number of monthly absences among its 125 employees. The following show the probability distribution for the number of absent days. So we have here the number of days absent and the probability of each number. So for example, if absent 1 day, the probability is 0.20. Okay, so the probability that an employee will absent 3 days, for example, is 0.15. What are the questions? What is the mean number of days absent? Well, the mean numbers, here we have a probability distribution. So the mean is called mu or EX, and it is summation X PX. So these are the values of X, and this is the probability of each one of them. So you just multiply 0 times 0.35 plus 1 times 0.20 plus 2 times 0.30 plus 3 times 0.15 and use the calculator, you will find that the answer is 1.25. So that's the correct answer. What is the probability an employee will be absent for 2 days or less? So he is asking that for the probability that X is less than or equal to 2 days, 2 days or less during a month. So here, 2 days or less means 1 or 0. So either you can find this probability by adding 0.35 plus 0.2 plus 0.30, or you can just say 1 minus probability of 3, which is 1 minus 0.15, which is 0.85, and C will be the correct answer. Notice that for a probability distribution to be correct, if you add all the probabilities here, you should get 1. Sum of all probabilities is 1, and the probability of each X is between 0 and 1. A box containing 7 green balls and 5 red balls. Okay, so we have 7 green and 5 red. If a ball is drawn at random from the box and turns out to be red, okay, so we choose a ball, draw a ball from the box, and it's red. If the red ball is returned to the box, so this means we have now in the box 7 green and 5 red again. So this is with placement. Okay, I mean we put the ball again. What is the probability that a red ball will be drawn on the second selection? Well, since we are putting the balls again that we draw, so the drawing a ball every time will be independent from the previous time. We have the same number of balls, the same number of red balls, the same number of green balls every time. So every time we select a ball, the probability of red balls would be the number of red balls, which is 5, over the total number of balls in the box, which is 5 plus 7. So the correct answer is 5 over 12. So really, this sentence doesn't change anything from the probability. When it changes, if we do not return the ball, if the ball is not returned to the box, then in this case we will not have 5 red balls, we will have 4 red balls in the second time, and the total number of balls would be 11, not 12 in the second time. then the probability in this case will be different. But here it is every time we select a red ball and put the ball again in the box, the probability of selecting red is 5/12, and the probability of selecting green is 7/12. For a binomial distribution with a sample size equal to 10, sample size, this is denoted by n, so small n is 10. A probability of success is denoted by small p equal to 0.3. What is the probability that the sample will contain exactly 3 successes? What is the probability that x equals to 3 or just 3? Well, the formula for the probability distribution, C, and we write n here, which is 10, and x here, which is 3. And then we multiply this by p, the probability of success, raised to x, which is 3. And then we find 1 minus 0.3, which is 0.7, and that's the probability of failure, that's q. And we raise it to the power 10 minus 3, which is 7. So this is the formula of the probability, the binomial probability distribution. And we can use the calculator and make sure that the answer in this case is 0.2668. Part B. An experiment may have only one result, two results, two or more, none of the above. Well, the definition of the experiment, an experiment is a process that produces a single outcome. That's the definition of the experiment. So only one result. So for example, if you toss a coin, you will get a single outcome, one result, either head or tail. Of course, the different possibilities of the outcomes of the results, this is called the sample space. But for the experiment, when you do an experiment, when you select something, you select only one. You get only one answer, okay? So an experiment is a process that produces a single outcome whose result is not predicted and cannot be predicted. And you don't know when you toss a coin, you will get a head or a tail. Z is a random variable that follows the standard normal distribution. What is the probability that Z is greater than 1.75? So he's asking probability that Z is greater than 1.75. Well, you can use the table for that, or you can use the calculator. If you use the table, this is the table, this is the Z table. Notice that we only have the probability between 0 and the Z value. So if you look to 1.75, if you search for 1.75, this is 1.7. This is 1.7. 1.75 would be 0.4599. So 0.4599 from the table, 0.4599 would be the probability between 0 and 1.75. But we need the probability that Z is greater than 1.75. So here is 1.75. We need this probability. But the table gives us this probability. So to find the probability of Z greater than 1.75, we know that the probability to the right of 0 is 0.5. So if you subtract 0.5 minus 0.4599, you get the correct probability, which is in this case 0.401. Okay. You can use the calculator. If you go to mode stat, press 3 stat, and then one variation, and then press on, go out, okay? And then shift stat, which is shift 1, shift stat, okay? And then press 5 distributions. In distributions, you have 1p, 2q, 3r. You use r here, the number 3. You press 3. R means probability to the right of something. So you write R 1.75 in the calculator. Just write 1.75 inside R, and you will get in the calculator this answer 0.40059. If you choose 4 decimals, then sorry, there is a 0 here. Okay, 0, 4, 0, 0. Just write up to here, but because this is 5, make this 1. So the correct answer would be 0.0401, either using the calculator or using the table. If two events A and B are mutually exclusive, well, remember the definition of mutually exclusive. Mutually exclusive means events like this, they have nothing in common. Their intersection is phi, so the probability of their intersection is 0. What does the special rule of addition state? Well, addition rule says how to find the probability of A or B. This is the addition rule, A or B. It's never negative, so this is not, D is not correct. P, A or B, we know that it is the probability of A plus probability of B minus the probability of the intersection, okay? But the intersection is phi, and the probability of the intersection in this case is 0, so this is 0. So the probability would be only probability of A plus probability of B for mutually exclusive sets. A study by the Ministry of Tourism revealed that 40% of the vacationers to Riyadh city visit the Riyadh Zoo. So we can say that probability of visiting Riyadh Zoo is 0.4. 0.5, 55% Riyadh malls. So we can say that probability that a visitor will go to a mall is 0.55. 35% visit both. Both means zoo and mall. So the intersection between the two is 0.35. The question, what is the probability that a vacationer will visit at least one of these attractions? Now, what is the meaning of at least one of them? It means either the zoo, that's enough, only the zoo, or means union, the mall, one of the malls. So that would be also enough. So if he visits a zoo, that's okay. If he visits a mall, that's okay. If he visits both, that's okay, because he says at least one of them. At least means either one or both of them. This means the union. That's the definition of the union. At least one means the union. So what is the union? It is what this rule which we just mentioned here. It is the probability of Z, which is 0.4, plus probability of M, which is 0.55, minus the probability of the intersection, which is 0.35. Because the intersection here, these two sets are not mutually exclusive. There is an intersection. There is a probability for the intersection. If you use the calculator and add and subtract, you will find that the answer is 0.6. Which one of the following is not a condition of binomial distribution? Well, in binomial distribution, we need the trials to be independent. We need, we only have two outcomes, and that's why we call it binomial. Probability of success remains constant from trial to trial. That's also correct. So the condition which is not a condition, at least 4 observations. No, n can be anything. For example, in this question, we just solved the question about the binomial. N is 10. So n could be anything. The number of observations could be anything. It's not necessarily 4 or less, 4 or more. It could be 3, it could be 2. That's okay. So 3 or 2 is okay. So at least 4 observations, that's not correct. Okay, question 10. A study of 200 computer science graduates revealed this monthly income. So this is the monthly income. Under 1,000, we have 102 graduates. Between 10,000 and 20,000, we have 60 and so on. What is the probability that when an employee is selected at random, that when he earns 10,000 or more? So he is asking that probability that X is greater than or equal to 10,000. Well, this is under 10,000, so we don't need it. This is between 10,000 and 20 and up to 20,000. So that's okay. 20,000 and more, that's also okay. So this will give you the probability. But remember, the probability cannot be 60 plus 38. These are the numbers. So we need to change it to probability. So we add 60 plus 38, but we need to divide by the total number of the graduates, which is 200. And if you use your calculator and divide, you will find that the probability is 0.49. So that's the correct answer. A statistics professor receives an average of 6 email. So that's the average. 6 email messages per day from students. Assume the number of messages approximates a Poisson distribution. Okay. So we have a Poisson distribution. What is the probability that on a randomly selected day? Notice that he said per day. And he said here, what is the probability that on a randomly selected day? So the number of segments is 1. You know that segments is denoted by t, so t is 1. And if t is 1, then the probability of x, the Poisson, would be lambda, which is the average to the power x, okay, times e to the power negative lambda. There is a t here, but t is 1 over x factorial. Usually it is lambda t, but if t is 1, so it's only lambda. Lambda is the average, so the average is 6. He said 6 email messages per day. And what is x? X is the one he is asking about. He says, what is the probability that on a randomly selected day, the professor receives 3 messages? This is x. So he is asking, what is the probability of x equals to 3? Lambda is 6. I raise it to the power x. And then e, which is in the calculator, the number e to the power negative lambda, and lambda is 6 over x, which is 3 factorial, and 3 factorial is also in the calculator. If you use the calculator and evaluate this, you will use that the answer is 0.0892 if you choose 4 decimals. Okay, that's the correct answer. 2 boxes contain balls. The first box contains 3 balls marked with letters A, B, and C. So we have in a first box A, B, and C, 3 balls. And in the second box, we have 2 balls, and they are marked E and F. What is the experiment? If the experiment of selecting 1 ball from the first box and 1 ball from the second box, what is the sample space? So when you do the experiment, when you select 1 ball from the first box and 1 ball from the second box, you will get only 1 result, okay? But what is the sample space? Sample space, all possible outcomes. So we do a tree diagram. First, let us start step by step. Let us select a ball from box 1. What are the possibilities? We can select ball A or B or C. So this is selecting a ball from the first box. Then now select a ball from the second box. If the ball selected from the first box is A, you can still select E or F from the second box. Also here, E or F, and here E or F. So in fact, the sample space consists of all of these possibilities, either ball E with ball A with ball E, or A with F, or B with E, or B with F, or C with E, or C with F. So there are 6 possibilities in this case, and this is the sample space. In a management trainee program, 80% of the trainees are female, okay, and 20% are male. So probability of female is 0.8 and probability of male is 0.2. From the record, 90% of the female are okay. So here, this is Bayes' theorem. We have females and males, it's good to deal with it with tree diagram. Probability of female is 0.8, probability of male is 0.2. And now 90% of the female attend college. So of the female, we have some of them attended college, some of them no, okay, do not or didn't. So the probability of 90% of the female attended college and 0.1 didn't. From the males, 70% of the males attended college and 0.3 did not, okay? So this tree diagram illustrates the experiments. A management trainee is selected at random. What is the probability that the selected person is a female given that she attended college? So we need probability of F given us. Well, 0.9 is probability of C given F. But how to find probability of F given C? Well, by definition, it is probability of F intersection C over probability of C. That's the probability of the given, okay? That's equal to. How to find the intersection from a tree diagram, F and C? Well, you find the intersection F and C by multiplying 0.8 times 0.9. And you find the probability of C. C comes from this branch and from this branch. So you multiply 0.8 times 0.9 plus, and you add to 0.2 times 0.7. This is how we find this probability. If you put it in the calculator, you will find that the answer is 36 over 43, or if you want, it's 0.8372 rounded to 4 decimal places. A board of directors consists of 6 men and 4 women. So we have 6 men and 4 women. So the total number of directors is 10. A 5-member search committee is to be chosen at random from the 10 to recommend a new company president. What's the probability that the search committee will consist 2 women, 3 men? So in fact, this is a hypergeometric distribution. Capital N here is 10 according to the symbols used in the books. And capital X is how many of them success, the number of success. If we choose men to be success, so we have 6 men, so I will call capital X 6, and small x, the sample we need to choose, a 5-member. So 5 will be small x. I mean, this is not x, this is n. Okay, this is the sample size, which is n. X, the number of men in the sample, which is 3, small x. So the probability of choosing 3 men and 2 women would be, you can say that always it's like this, CC over C, that's the hypergeometric distribution. Capital N, which is the total number of people, of directors. We need to choose how many of them. We need to choose 5. So you put it here. And these 10 are divided into, we have 6 men and 4 women, okay? So these 10 are divided into 6 and 4. And these 5 that we need to choose 3 men, so 3 out of 6, and 2 out for 2 women. And you can use the calculator. C is the bottom division, above division, you have NCR. This is NCR. So if you use the calculator to find this, you will find that the answer is 10 over 21. If you want to write it as decimal, it's enough to write it as 10 over 21. That's the accurate answer, but you can also change it to decimals like this. The grades of students in the final exam are normally distributed, and this is mu and this is sigma. Find the probability that students selected will have a grade between 22 and 31. Well, grades, this is the distribution, okay, the random variable, and this X follows a a normal distribution. So we need the probability that x is between, the grade is between 22 and 31. And to find this probability, we change it to z, and z is x minus mu over sigma. So it would be 22, we subtract from 25, which is mu, over sigma, which is 5, less than or equal to, if you subtract mu over sigma, you will go to z, less than or equal to 31 minus 25 over 5. If you use the calculator, you'll find that this is the probability that negative 0.6 less than or equal to z less than or equal to 1.2. And to find this probability, you have to understand the table. Well, the table, this is 0. Negative 0.6 will be somewhere here, and 1.2 will be somewhere here. So we need this probability, we need this area. And noticing that the table gives us this area from 0 to something. So if you just find the area from 0 to 1.2, add this to the area from 0 to negative 0.6. There is no negative, but the area from 0 to negative 0.6 is the same as the area from 0 to 0.6. So it's enough to find the area from z to 0.6 plus the area from z to 1.2. So you go to the table, you look to 0.6, 0.2257. Okay, this is 0.6, this is 0.2257. So 0.2257. And then you go to 1.2, and this is 1.2, 0.3849, 0.3849, and you add, and you get the answer 0.6106. You can use the calculator if you like. Similarly, we said that there are, if you go to distributions, there are, of course, you have to follow the steps I mentioned earlier. If you press 5, which is distributions, you have P, R, and Q. We said R, find the probability to the right. Q gives you the probability between 0 and 1.2. It gives you the probability in the table. So you can find Q 0.6 plus Q 1.2, and you will reach the same answer. I guess this is the last question here. Thank you very much. I hope you enjoyed this video.